So today we are going to look at Lesson 23, Solution Sets to Simultaneous Equations. Opening exercise. Here is a system of two linear equations. Verify that the solution to this system is 3, 4. So we are given two equations, and we are to verify that the solution to the system is 3, 4. So in order to verify something, we simply have to plug in. So y equals x plus 1. Our y is 4 equals x is 3 plus 1. 4 equals 4. That's a true statement, so it works for A1. Now let's check for A2. Y equals 4 equals negative 2 times the x is 3 plus 10. So 4 equals negative 6 plus 10. 4 equals negative 6 plus 10 is 4. So this works. So 3, 4 is a solution to the system. Let's look at, so skip over to your notes, to the example. Why does the elimination method work? So this lesson is focusing on the elimination method. And we are asked to solve this algebraically, focusing again on the elimination method. So we are given an original system, 2x plus y equals 6, and x minus 3y equals negative 11. So let's look at these two equations and see what we can change, specifically what can we multiply one of these by to look like the other. So for example, let's look at the x's here. I've got 2x and I've got x. So I can multiply x by the bottom equation by 2, and these would now match. But if I'm trying to eliminate a variable, I want to make it negative. So I'm going to multiply this entire equation by negative 2. So let me first bring over the top system. So 2x plus y equals 6. And now after I've distributed a negative 2 all the way through, I've got negative 2x. Negative 2 times negative 3y would be positive 6y equals negative 2 times negative 11. Don't forget the n equals positive 22. And now I can solve this by elimination. So if you look at our system here, 2x minus 2x cancels, it eliminates. That's the whole purpose of the elimination method. We're trying to eliminate a variable. We've got 1y plus 6y gives us 7y equals 6 and 22. 22 is positive, so we're going to add 6 plus 22 is 28. Divide by 7 on both sides. Y equals 4. Just like with all systems, we have to have an x and a y. So now we're going to plug this y value in to either of the original equations to solve for x. So I'm going to plug it in the top one. So I've got 2x plus y. I just found y is 4 equals 6. 2x equals 2 after I subtract 4 on both sides. Divide by 2 on both sides. X equals 1. So my solution is 1, 4. X, y. I'm now going to work this same exact problem, except I'm going to do a different way. Still solving by elimination, except this time I'm going to multiply the top equation by 3. And I'm multiplying the top equation by 3 so that my y's can be the same. So if you see, once I distribute this, I will get positive 3y, and I know 3y minus 3y will cancel out. So now let me distribute 3 all the way through. So this gives me 6x plus 3y equals 18. Don't forget to distribute that. And then let me bring over the bottom one. X minus 3y equals negative 11. So this is what I was talking about a second ago. So on the last one, I decided to multiply to eliminate the x. This time I decided to multiply to eliminate the y. So if you see now, my y's eliminate. If there's not a sign, you can assume it to be positive, so we can add. 6x plus x is 7x equals 18 minus 11 is 7. Divide by 7 on both sides, x equals 1. Again, we're going to plug this value into either one of the original equations. So we're going to plug into the original one. So I've got 2x, I just found x is 1, plus y equals 6. 2 plus y equals 6. Subtract 2 on both sides to solve for y. Y equals 4. And my solution is still 1, 4. So to clarify, I got the same answer. I used the elimination method both times, this time and the last time. I just multiplied by a different number because I was eliminating different variables in both problems. So you would just have to pick one of those ways to decide. Let's look at exercise 1. Explain a way to create a new system of equations with the same solution as the original that eliminates the variable y from one equation. Then determine the solution. So let's look at the y. Let's look at the y. What could I multiply this y by so that it can eliminate 3y? Well, it would have to be negative 3y here, which means I would have to multiply the bottom by 3. So let me first bring over my top equation. So 2x plus 3y equals 7. And after I distribute 3 all the way through, I've got 3x minus 3y equals 3. So just like the problem asked for, I'm eliminating y. 3y minus 3y is gone. Again, I'm going to add 2x and 3x since it's positive. So I'm left with 5x equals 7 plus 3 is 10. Divide by 5 on both sides, x equals 2. And now I'm going to plug 2 in for x in either one of the original equations. So 2 times x, so 2 times 2, plus 3y equals 7. 2 times 2 is 4, plus 3y equals 7. Subtract 4 on both sides, and I'm left with 3y equals 3. So y equals 1. And so I would write my solution as x, which is 2, 1. Now let's look at exercise 2. Same information, same system. This time the directions say to find a way to eliminate or to solve this using the elimination method that eliminates variable x. So on exercise 1, we were eliminating variable y. So now we're going to solve this by eliminating x. So look at your x values here, or look at your x position. We've got 2x and I've got x. So in order to eliminate this, I need to multiply the bottom by negative 2. Because then that would give me negative 2x on the bottom. We distribute this all the way through. Plus 2y equals negative 2. Don't forget that last one as well. And then I just have to bring over the top equation. 2x plus 3y equals 7. And now, just as the question asked, I can eliminate variable x because 2x minus 2x is gone. 3y plus 2y is 5y. 7 minus 2 is 5. Divide by 5, y equals 1. I now substitute this value into either one of the original equations. So I'll pick the top like usual. 2x plus 3 times y, we just found y is 1, equals 7. 2x plus 3 equals 7. Subtract 3 on both sides, 2x equals 4. Divide by 2, x equals 2. So I would write my solution as x, which is 2, comma, y, which is 1. So as you can see, on exercises 1 and 2, we got the same solution, which is correct because we were working with the same system. There is just multiple ways to solve it algebraically, and specifically we use the elimination method on both of these exercises. In one exercise, we eliminated variable y, and in this exercise, we eliminated variable x. these are practice problems. They are not in your notes, but I really encourage you to work through these. They're very good. So if you're watching this at home, if you want to pause the video and try to work through some of these, that would be good, or you can follow along. So this first problem, let's look to see if something is already set up for us to eliminate. And if you look carefully, our x's can't eliminate. Okay, but look at our y's. We've got negative y, which is really negative 1y, plus 1y. And those cancel because negative 1 plus 1 is gone, which means we don't have to multiply and rewrite a new system. So now let's look at what's left. This would be x plus 2x, so that's 3x equals 11 plus 19 is 30. Divide by 3 on both sides, x equals 10. Now I'm going to plug 10 in to either equation to solve for y. So I've got x, so 10 minus y equals 11. I subtract 10 on both sides, so negative y equals 1. Now I need to divide by negative 1 to make that variable positive, so y equals negative 1. So my solution would be x, so 10 comma negative 1. Now let's look at number 2. Is there anything that is set up already for us to eliminate? Let's look at our x's. So this would be negative 6x plus 6x. Do those eliminate? Yes, they do, because negative 6 plus 6 is 0. So now I can look at what's left. 5y plus 4y is 9y, and 1 minus 10 is negative 9. Divide by 9 on both sides, y equals negative 1. Now I'm going to plug my value in to either equation to solve for the other missing variable. So negative 6x plus 5 times y, we just found what y was. Simplify and solve. Add 5 to both sides. And divide by negative 6, so x equals negative 1. So our solution is x, which is negative 1, comma, our y is negative 1. So negative 1 is our solution. Let's look at number 3. Let's see if our x's eliminate. Negative 4x plus x, that does not eliminate. And 9y minus 3y, that does not eliminate. Which means we will need to multiply at least one of these so that we can eliminate it. So let's look at the x's. What can we multiply this bottom equation by to eliminate a variable in the top? We can multiply the bottom by positive 4, and that would give us on the bottom 4x minus 12y equals negative 24. Remember to distribute whatever you multiply by all the way through. And now we can carry over our top equation. Negative 4x plus 9y equals 9. So now you may be able to see why I multiplied the bottom by 4, because negative 4x plus 4x is going to cancel. 9y minus 12y is negative 3y. And 9 minus 24 is negative 15. Divide by negative 3 on both sides, y equals 5. Just like every other method, I got to plug in this value to find the other missing value. Negative 4x plus 9 times my y, I just found y, equals 9. Negative 4x plus 45 equals 9. Subtract 45 on both sides. 9 minus 45 is negative 36. And divide by negative 4 on both sides. X equals 9. So my solution is x, which is 9, comma, 5. Let's look at number 4. So again, there are different ways in which you can eliminate a variable. So this time, let's look at 4. Just by looking at it, the x's don't eliminate and the y's don't eliminate, so we are going to have to change one of our equations. So the easiest way it looks like is if we multiply the bottom equation by 2, because that would give me a negative 16x out front, and 16 minus 16 would cancel out. So let's rewrite this bottom equation, distribute the 2 all the way through, negative 16x minus 12y equals 12, because I distributed this 2 all the way through. And then bring over your top equation, line it up, 16x minus 10y equals 10. And now you can solve this. 16x minus 16x is going to cancel. Negative 10 minus 12y is negative 22y. And 10 plus 12 will give you 22. Divide by negative 22. Y equals negative 1. Now we will plug this value in to find the other value. So 16x minus 10 times y we just found. Simplify and solve. 16x plus 10, since it's a negative times a negative. Subtract 10, we're left with 16x equals 0. Don't get confused here, we can still keep going. We need to divide by 16 on both sides, and 0 divided by anything is 0. So my solution to this system is 0, negative 1. Here's some more additional practice problems I would encourage you to work through. So let's look at this problem. Just looking at it, my x's don't eliminate. My y's are really close to eliminating. The only way they can eliminate is if one of them becomes a negative, which means I can easily multiply the bottom, or the top for that matter, by a negative. So if I do that, my new bottom is positive 3x minus y equals positive 5, because I'm distributing negative all the way through. And then bring the top equation over. Now, if you look, your y's cancel. This is 8x, 3x. They're positive, so 8x plus 3x is 11x. And negative 16 plus 5 is negative 11. Divide by 11, x equals negative 1. And like usual, we'll plug in this value to find the missing value. 8 times x, 8 times negative 1, plus y equals 16, negative 16, excuse me. Negative 8 plus y equals negative 16. Add 8 to both sides because it's negative, and negative 16 plus 8 would be negative 8, which means our solution to this equation, or this system rather, is negative 1, negative 8. Let's look at another one. So looking at this one again, you notice that your x's can't cancel on their own and the y's can't cancel on their own. So we have a couple of options here. One option would be you could multiply the bottom by a negative 4, because then that would give you a positive 4x and those would cancel. Another option would be to multiply the bottom again by positive 3, because then that would give you a 15y, and your y's can cancel out. Negative 15 plus 15. So let's do that. Let's do this one. So if we multiply the whole bottom by 3, that would give us negative 3x plus 15y equals negative 39. Bring over the top, negative 4x minus 15y equals negative 17. Now your y's cancel. Negative 15 plus 15 is gone. Negative 4 minus 3 is negative 7x. Negative 17 minus 39 is negative 56. Divide by negative 7 on both sides. Negative 56 divided by negative 7 is 8. Now let's plug in 8 to find our missing value. Negative 4x, negative 4 times 8, minus 15y is equal to negative 17. Negative 32 minus 15y is equal to negative 17. I'm going to add 32 to get rid of it. So So this leaves me with negative 15y. Negative 17 plus 32 is 15. Divide by negative 15 on both sides. Y equals negative 1, which means our solution is 8, negative 1. So again, if you decided to multiply the bottom by negative 4 to make it a positive 4x on the bottom, you would still get the same solution. That is all for lesson 23. If you would like additional practice, I would encourage you to do a simple Google search, solving systems of equations by elimination, and you will probably come across thousands that can assist you. Stay tuned for more.